Welcome to RLD Academy. In this video, we'll solve this problem, and you can see that this equation is having highest power 4. So this equation will have 4 solutions, and we need to find out all the 4 solutions. The solution could be real or complex, and they could be equal or unequal. We need to find all the 4 solutions. I'll present you 2 methods to solve this problem. In the first method, we'll try to find or deduce this equation to second order equations, quadratic equations, so that we can solve that quadratic equation. And in the second method, we'll use Euler's formula. Both the methods are interesting. Now just follow this video to get these 2 methods. What we'll do first, we'll divide both sides by x square. And this method will work if the coefficient of x to the power 4 and this one constant one, if it is same. And again, the coefficient of x cube and x, if they are again same, then this method, the following method will work. Okay, so we'll divide this polynomial by x square, and we'll use that concept that x is not equal to 0. Obviously, for the x0 is not a solution of this equation, right? Because if I put x equal to 0, all at 0, it is 1. So x0 is not a solution, right? So if I divide x square, then you see x4 upon x square it will become x square. X cube upon x square is x. Then this will cancel, it is 1. Then it is 1 upon x, and this will be 1 upon x square. Now I'll rearrange this equation a little bit. The first term and last term I'll combine together. Then these two I'll consider first, x plus 1 upon x, and then last one is 1. Now I want to get one second order equations of this form, the square of this one. So this x square plus 1 upon x square I want to replace by the square of x plus 1 upon x. Okay, so what we will do, this is the form a square plus b square, and a square plus b square we can replace by a plus b, that whole square, minus 2ab, right? So if I use that one, then it will become x plus 1 upon x whole square minus 2 into x into 1 upon x, and this x and x will cancel. Okay, thus you will see that this is the whole square part, and this is your x plus 1 upon x, same thing. And now this is minus 2 and this is plus 1. The 2 I can combine, it will give you minus 1. Thus the final equation is this one. Okay, now I can replace x plus 1 upon x by another variable y. Then we'll get y square plus y minus 1 equal to 0. This is one quadratic equation that we can solve, right? The value for y, we can solve it using the CSIR formula. If ax square plus bx plus c equal to 0, this is a quadratic equation. Its solution is given by x equals to minus b, this is your b, coefficient of b, x minus b plus minus square root b square minus 4a into c upon 2a. Now in this case, a equal to 1, b equal to 1, and c equal to minus 1, right? So y will be, it is minus b means minus 1, plus minus b square 1 square, minus 4ac, a is 1 and c is minus 1 that I have used, by 2a, a is 1. Okay, so if you simplify this, here you will see minus 1 is plus, it is 4, 1 plus 4 is 5. So minus 1 plus minus square root 5 upon 2, this one, right? So this is the solution for y. So that I will keep it here. Okay, this is that replacement I have done. X plus 1 upon x equal to y. Then we have got one quadratic equation for these final equations, and there we have obtained the solution for y equals to -1 plus minus square root 5 by 2. Now we have replaced this thing, no? X plus 1 upon x equal to y. Once y is known, then this will give you another quadratic equation, because if I multiply this one, it's x squared plus 1, and this is y into x. So this is our next quadratic equation, x squared minus yx plus 1 equal to 0. Again, I'll use same thing, Caesar-Hodges formula. In this case, a equal to 1 and b equals to minus y and c equal to 1. Okay, and y is known to us, this one. Okay, now what is x? X we can represent that. This is minus b, means it is y only, plus minus b squared minus 4ac, a and c both are 1, so it is 4 simply, and upon 2 into 1 is 2. Okay, so we need to compute this thing, then we will get final result x. Now we have two solutions for y. For two solutions of y, again I will, for each solution of y, I'll get two solutions for x. So total solution will be 4. Okay. So case 1, I'll consider first solution. When y equals to, if this is positive, then root 5 minus 1 by 2, that one. So the y is positive actually, but you can see that its value is less than 2, because root 5 is less than 3, 2 point something, minus 1 equals to 1 point something by 2 is obviously less than 2. So if y is less than 2, then y square minus 4, this will become negative. So the square root of y square minus 4, it will give you imaginary quantity. So this is real and this is imaginary. You will get a complex result. Okay, and obviously complex and conjugate. Okay, because one is plus, one is minus. And you can see that the solutions of this equation, when all this polynomial is having real coefficients, then if equation is having one complex root, then obviously there should be corresponding conjugate part. Otherwise the polynomial cannot be real. Okay, so they should be in conjugate pair always. That is true. Now we will calculate this x equal to, so this is your y by 2, first real part. So this is root 5 minus 1 by 2, it was there. So by 2 means it will become 4. Root 5 minus 1 by 4. And this is there, I'll put plus minus sign. And already I'll consider the I, because this is negative, you know. And we'll put I outside. And here it will consider 4 minus y square. 4 minus this square. And this 2 is outside. Right? So if you simplify this one, then you will see that you will get this value. So it is very simple. This is 4, 2 square is 4, 4, 4, 16. And if you expand this one, it is 5. This square root 5 square is 5. And last one is 1 square is 1. So 5 plus 1 is 6. So 16 minus 6, it will give you 10. And minus 2ab. And it is minus sign plus 2ab. So it is 2 into root 5. Okay. So this is for y equals to square root 5 minus 1 by 2. Now second case, second value of y, when y equal to minus, it is also minus sign, minus square root 5 minus 1 upon 4. So I am considering it is magnitude. Magnitude of y is less than 2. Again, because square root 5, this is 2 point something. So 2 plus 1 is 3 point something. 3 point something by 4 is obviously less than 2. Right? So this is not 4, this is 2 actually, sorry. This is 2, but in this value will be less than 2. Right? So plus minus square root 5 plus 1 upon 2. So this you should consider as a 2. Okay, that should be less than 2. So for that, we'll consider this one, the solution. Solution is again y by 2. So this is square root 5 plus 1 by 2. Again 2 is becoming 4. So make this correction. This is equal to 2. And plus minus, again I. And this is 4. And this value, if you calculate 4 minus y square, then you will get similar thing. Just only here it was plus sign. Thus, you will get minus sign here. So it is 10 minus 2 root 5. Okay, so we have got all the solutions for x. What are solutions? These are solutions. X equals to square root 5 minus 1 upon 4 plus minus I square root 10 plus 2 root 5 upon 4. This conjugate pair, or this one minus sign root 5 plus 1 upon 4 plus minus square root I square root 10 minus 2 root 5 by 4. Okay. Now if we place these 4 points on the complex plane, then it will look like this. First, these 2 points are for this pair. This is real part, root 5 minus 1 upon 4. This is real part, and this is the imaginary part. Okay, so this is the point with this plus sign, and for minus sign, this is the conjugate pair, right? Similarly, for this one, we'll get on the left hand side, this negative sign is real part is negative. This side, these 2 points, right? Now it is interesting to see that all the 4 points will lie on a circle. This circle with radius 1, meaning is that magnitude of this x is always 1. You can check its square plus this square, it will give you 1. Again, this is square plus this square, again it will give you 1. Okay, right. Now we'll try to solve the same problem using the second method, this one. Now here already I have solved one problem, x to the power 8 equals to 16 in a previous video. So I'll suggest you to follow this video. So that link will be given here. Okay, and we'll follow similar approach to find all the solutions at a time using Euler's formula. I may not discuss everything in detail again, so please follow the video. Okay, if you have any confusion, you can follow that one. Now what I'll do, so this equation, now I'll multiply both sides by x minus 1. So if I multiply by one factor x minus 1 left hand side, so this polynomial now it will become its power, highest power will become 5, so fifth order polynomial. So it will have 5 solutions. But remember, already I have introduced one known solution, that is x equal to 1, because x minus 1 is a factor. So I'll get ultimately fifth order solution equation polynomial on left hand side. But we know that one solution is 1, and rest 4 solutions we need to find out. And that will be, those solutions will be the solution for the original problem. Okay. Now if I multiply these two, you can see that if I multiply x with this one, then I'll get x5 plus x4 plus x cube plus x square plus x, right? And then minus 1, if I multiply on this one, I'll get minus 1 x4, then minus x cube, minus x square, minus x, and minus 1 into minus 1 is minus 1. And right side is 0 into something is 0 again. Okay, now you can see that this will cancel except the first and last one. So you will get x5 minus 1 equal to 0. So it is x5 equals to 1. So this problem is exactly similar to previous problem, x to the power 8 equals to 16. The same approach we will take now. So again, in this one solution is already known to us, that is x equal to 1, that we have introduced. And rest 4 solutions is exactly we need to compute, and those solutions will be the solution for the original problem. Okay, right. So this is the reduction. So from this one we have got x5 equal to 1. Now 1 I can consider as a 1 angle 0 degree, and you can see that this one point is here, angle 0 degree. Now same angle we can get after rotation of 2 pi, or again one more rotation 2 pi. So 2 pi, 4 pi, 6 pi, like that. So integer multiple of 2 pi will give you again the same point 1. Thus this one I can replace in general form, the magnitude 1 and phase is integer multiple of 2 pi. So we can write as 1 magnitude, and using Euler's form, e to the power I theta, the phase is 2n pi, where n equals to 0, plus minus 1, plus minus 2, all those things. Okay, I have discussed this thing in detail in my previous video, so please follow that video. Okay, now it is very easy to compute all the 5 solutions. So x is very simple. Now I'll take 1/5 root of this one, so its magnitude is 1. 1 to the power 1 by 5 is again 1, and here it will become e to the power I 2n pi upon 5. Okay, it's whole to the power 1 upon 5. 1 upon 5 is multiplied, so it is 2n pi by 5. Now we need to vary n from n equal to 0 to 4 to get all the 5 solutions. Okay, now I'll consider n and x. Say n I'll consider from 0, 1, 2, 3, 4. I'll get corresponding solutions. So when n equal to 0, you can see that this is d part 0 is 1, so x equal to 1. However, this solution is not exactly the solution for this equation, because we have introduced x equal to 1 solution. Thus we have got x to the 5 equals to 1. So I will not show it here. Okay. Second one, with n equals to 1, I'll get 1 into e to the power I times 2 pi upon 5. Now 2 pi upon 5 is 360 by 5 means 72 degree. So phase is 72 degree. So that we can write cos theta plus I sin theta, cos 72 degree plus I sin 72 degree. And cos 72 degree, we can find that root 5 minus 1 upon 4. And sin 72 degree is square root 10 plus 2 root 5 upon 4. So these two values we can calculate. In some video we will show this one. Okay, it's not very difficult to calculate these two values. So here you can see the phase is 72 degree and magnitude is 1, so point is here. This is the corresponding complex solution. Okay, real part is square root 5 minus 1 upon 4, and this is the imaginary part. Now if I go for n equal to 2, then it will be e to the power I 4 upon 5 upon 5. That means double of previous angle. So it is earlier 72 degree. Now it is 144 degree. If it is 144, this angle is 36 degree. So it will be in second quadrant. So this point is the solution. So this real axis, this magnitude is cos 36 degree. Again, but negative side, minus sign. Okay, and this is your sin 36 degree. Okay, so now if I consider n equal to 3, so already I have got two solutions. One is on right side, on the other side, and we know that these two are both are complex. So we should get another two solutions. Those should be conjugate of these two solutions. So one will be conjugate of this one, could be here, and other one will be conjugate of this one, could be here. Okay. So you see n equal to 3, I'll get e to the power I 6 pi by 5. This is solution. Another 72 degree here. Okay, means 216 degree total. This point will be here. So another 72 degree, if you consider, it will be in fourth quadrant. So this is the conjugate pair of this one. Okay, so remember, so this solution is conjugate of this one, means minus square root 5 plus 1 over 4 minus I square root 10 minus square root 2 root 5 upon 4. And this will be the conjugate pair of this first one. Okay, so these are the all solutions for this equation. I hope you have enjoyed this video. So you may press the like button if you have enjoyed really. Okay, so thanks for watching.